Well, hello again. We're in section 2.2. Section 2.2 is about slopes of lines. The various things we're going to talk about are slopes of line segments, computing slopes using various ways of thinking about it. Saying the slope could also be computed by seeing what the change in y is when x increases by 1 unit. Determining whether slopes are positive or negative by looking at the way the line segment looks, or the line that the line segment's part of. And then finding relations between the slopes of parallel and perpendicular lines. And finally, interpreting slope as the average rate of change. Kind of a lot to do, so there's going to be a lot of screens that we have to go through. But we'll start off with slopes of line segments. All right, slopes of line segments. Well, for a line segment, I need 2 points. So we have a point P with coordinates x1 and y1. And Q with coordinates x2 and y2, like that. Then the slope is defined by the fraction y2 minus y1 over x2 minus x1. Okay, and ordinarily we're going to call slope m. Reserve the letter m to stand for slope. And we'll think of the change, the y2 minus y1 as how much y changes as we move between the 2 points. So we could call it the change in y, or I'll call it change in y. And right down here, we'll write the change in x. So that's how much x changes as you move between the 2 points. So we'll be looking at this in more detail in a minute. We have some notation for change, though. Change is delta represents change. Change in y over change in x, like that. All right. Now this is going to work out fine, except if the line segment is vertical, the x-coordinates will be the same, and you'll be dividing by 0, which is not a good idea. So we'll say that slope is not defined for vertical, having trouble spelling today, line segments. Otherwise, we'll get a number for every line segment. And we'll make the statement that every segment that is part of the line has the same slope. Okay. So the slope of the line is the slope of any segment that's part of the line. I'm looking at my notes. I'll just write that down. The slope of a line is the slope of any segment that is part of the line. So are we on our little scheme here? We talked about slopes of line segments, how you compute them. We talked about slope being rise over run. And we didn't quite get to this thing yet, so we're sitting right about here. You can see why that would be, but we'll be, because that'll make delta x, unit increase in x make delta x equal to 1. and the slope is delta y over 1, would make the change in y equal to the slope. But we'll be looking at this on the next screen, so let's get ready to move on.